Hello friends, welcome to our channel Google Galaxy. Today we are going to discuss the types of ligands. It's the second part of coordination compounds. Before continuing with this lecture, make sure that you have already seen the previous parts. Today we are going to discuss types of ligands. What does chelation and denticity means? These concepts are somehow important. Without recognizing the types of ligands, you cannot do you cannot do competitive exams, questions, or different types of numericals. So, starting with the ligands. When we talk about the ligands, it is also known as electron donor species. What we call it as? We call it as electron donor species. This is the another name of ligands. When we say ligands, it automatically means that ligands are electron donor molecules, or we can say species, which may be neutral, anionic, or cationic, which are linked with the central metal atom. For example, I am having this type of compound. This type of compound here, cyanide is acting as a ligand, and where silver is acting as a central atom. So these type of coordination are called coordination bonds. In fact, the electron needed for the bond are provided by the ligands. Thus ligands are the Lewis bases. As I told earlier, who are Lewis acids? Lewis acids are central atom. We call it as Lewis bases. Basically, they are having we call it as Lewis acids. We called ligands as Lewis bases. Why they are called bases? Because electron needed for the bond are provided by the ligands. Sometimes ligands are known as dentates. I am going to discuss later dentates in detail. You have to just learn the term right now that the ligands are sometimes called dentates. These are called dentates. It is derived from the Latin name called teeth. They may be compared to the teeth since they are surrounded by the metal atom or ion, in the same way as the tongue have surrounded as the teeth have surrounded by the tongue. Now next move towards the types of ligands. Types of ligands. The atom or ion which donates electron pair, I'll repeat, an electron pair in the ligand are called donor atom. Here cyanide is acting as a donor atom, or who donates the electron pair or ion. Depending upon the number of such of donor atom present in coordination, the ligands have been classified into the different types. It may be unidentate. It is also known as monodentate ligands. They are having one type of donor atom with the lone pair of electron. It may be neutral or anionic. When we talk about the neutral, maybe your question will talk about the water, oxygen having the lone pair. One thing to be careful, that the we called pair as uni, that means one. If more than one pair, how pair formed? When the two electrons combine to form one pair. Here I am talking about the one pair. Similarly, if an atom or a group is having, we called as bidentate, it means they are having more than one electron pair. We called it as, here we called it as one pair. One pair means two electrons. Another example of neutral is ammonia, nitrogen having excess of electrons. Next, these are the examples for neutral. Then we talk about the anionic. As I told, that the unidentate may be neutral or anionic. Be careful about it. I am talking about the neutral and anionic, not cationic. Anionic. It may be hydroxyl, it may be cyanide, it may be any halogen, it may be CH3CO-, it may be NO3, it may be NO2. There are numerous examples of anionic. It may be ONO-, etc. These are the types of unidentate. When we talk about the second type of ligand, which is also acting as Lewis base, because it provides the electron needed. When we talk about the bidentate, bi means two. It is sometimes also called as didentate. Need not to confuse. Bidentate ligands. These are the ligands which have two donor atoms and have the ability, I'll repeat again, it has to donate. What to donate? By the two donor atom donate. Who will donate? Two donor atoms will donate their electrons to make the acid stable and have the ability. The second point is, it has the ability, and the bidentate have the ability to link the central atom at two positions. Bidentate will link itself to two positions. I'll give the example. Few of the examples you need to cram, or I can say understand properly. After that, after understanding, you will cram it. Clear? It will help you later on. When we talk about the oxalate ion, we will abbreviate it as OX. OX is the short form of oxalate ion. We will draw the structure of oxalate ion as, be careful, we need the two electron pair. Here a single electron pair is available. For bidentate we need the two electron pair. Here what we see, that the electrons, here oxygens, are having excess of electrons. So these, because of these two oxygens, we called it as, they will support the Lewis acid whenever they see the complex ion. They will support by donating the two atoms to link with the central atom at two positions. This is the structure of oxalate ion. You will learn as it is, the structure of oxalate ion. When we are having this one is important, ethane 1,2 diamine Wherever you see En, it means we are talking about the ethane 1,2-diamine. You will know why we use this short form. It is because their structure is somehow complex. When we draw its isomers, when we draw some geometrical or optical isomers further in the chapter, it's not possible to draw the whole structure at that place. We will write its short form. This is represented as En. Now you will have to just understand the structure and cram it. Why you have to cram? Because they are already already verified by the scientist that we cannot modify these type of structures. The scientist already got the Nobel Prize for drawing their structures. So from now onwards, we will say that wherever you see this type of compound, you will have to write as it is, and teacher will not deduct your marks. Next we are having the sulfate ion. We are talking about the bidentate examples. Next we are having the sulfate ion. Sulfate ion. We will say when sulfate ion, I'll draw the structure because during my time I had learned these all examples with their structures. These are the few examples of bidentate. Another one we are having the glycinate ion. Glycinate ion. It is represented by the short form GLY. GLY. Here we will get the NH2 amine. Here NH2 is present over here. NH2. This is the structure of glycinate ion. These are the examples of bidentate. Now we are going to discuss with the third one, our polydentate ligand. When we talk about the polydentate, third we are having the polydentate. They are, as we discussing the types of ligands further, the structure getting more complex. So what you need to do is you need to just understand 2 or 3 structures. After that you will understand what I am going to say. So we can say polydentates are those who, I'll say a ligand with more than 1 donor atoms, with more than 2 donor atoms, sorry. When we say ligand is going to support, is going to help the central atom by giving support of with more than 2 donor atoms. We called it as polydentate. Another name of polydentate is multidentate. I'll give you the example. For example, giving an example of diene. This one is the short form of diethyl inner triamine. I'll give you the structure. You will have to just look for the structure. I don't think so you need to, because you are doing the basics of chemistry. Chemistry is not going to complex. When you will do any type of graduation, when you will do graduation in chemistry, during that time you will have to suffer from these complex structure and their properties. This one is the structure of diene. As I told, this is tridentate, or we can say polydentate. It will give away the 3 donor atoms to support the central atom. These are the examples. You need not to go to the complex structures. You have to just understand what are the types. Next we are going to discuss about the denticity and another concept of chelation. Here we are going to discuss denticity, and chelation. Maybe I spelled wrong, but as I am an Indian, so you must have to understand what I am going to say. It's a type of pronunciation varies with the country. So I'll say, if a ligand with more than two, I'll repeat again, if a ligand, I'm having any type of ligand with two or more electron donor group, ligand is going to donate, ligand having two or more electron donor groups. And what about its position? Its position in such a way that 5 or 6 members made a ring around the central metal atom. When we talk about the bidentate, it will link towards its 2 position, and when we talk about the on this topic, denticity and chelation, we will say a ligand will donate 2 or more electrons having 2 or more donor groups. And what about its position? Its position would be always in the form of ring, 5 or 6 members, 6 or 5 members form a ring around or I can say with central metal line, Then the ligands are termed as chelating ligands. Then the ligands are known as chelating ligands. If these two conditions satisfy your condition, then you will say these ligands are acting as a chelating ligands, and the ring is called chelate ring, and the ring is known as chelate ring. The complex which is termed the complex formed after getting these two things, after satisfying these two things, the complex means a compound within a square bracket. This complex is termed as metal chelate. This term is, we can say the complex will termed as metal chelate, and this property is called chelation, then this property is called chelation. The word chelate has been derived from the Greek word which means claw. And which means claw. A few examples of the complexes resulting from chelations I am going to list over here. The first one, we are having the bidentate or didentate chelation. I'll repeat again, it forms a ring and the ligands having 2 or more electron donor groups. The compound, I'll give you the example. The compound this type of compound in which bidentate is represented by this compound in which ethane 1,2 amine. It means we are talking about the En. Wherever you see En, it means one ethane. As I discussed before, few minutes before, what does En means? It means ethane 1,2 diamine is the chelating ligand. I'll draw the structure. Here platinum is present over here with the 2 chlorine. And one thing to be careful while calculating the coordination number, we need to calculate always number of sigma bonds. This type of structure is this one is a structure representing the bidentate, and here En is acting as a chelating ligand. Next we are having the terdentate chelation. When we say terdentate chelation, it is illustrated by the example diene, in which chelating ligand is terdentate ligand. Similarly, we are having another example of tetradentate chelation. The tetrachelation is shown by the complex. You will have to learn the examples as it is. The teacher may discuss, I'll repeat again, may discuss the same examples. In this, the chelating, the tri, and is a chelating ligands having 4 donor atoms. Okay, so further, the chelates are more stable. These are more stable than ordinary complexes. The stabilization of coordination compound due to chelation is called chelate effect. These are quite useful in industry as well as laboratory. These are employed in softening of hot water. The things I'm saying are very much important. These are employed in softening of hot water, in the separation of lanthanoids and actinoids. Separation of lanthanoids or actinoids. They are also find application in detection as well as estimation of some metals such as nickel, magnesium, copper like ions. Clear? These are the examples we need to look out carefully.